Welcome to physics class. Today I am going to discuss NCERT examples. See example 9.1. Let's solve some numericals of NCERT, page number 120. Example 9.1. See the statement. A constant force acts on object of mass 5 kg for a duration of 2 seconds. That means a constant force is applied on a given mass for 2 seconds. That means what is given? Mass is given 5 kg. Time is given 2 seconds. It increases object's velocity from 3 meter per second to 7 meter per second. That means this constant force is responsible for changing the velocity of the object. That means initial velocity given 3 meter per second and final velocity is given 7 meter per second. Find the magnitude of the applied force. Force we have to find, and if the force was applied for 5 seconds, if the same force was applied for 5 seconds, what would be the final velocity of the object? That means for 5 seconds we have to find the final velocity of the object. See the first part. We have to calculate the force. F is equal to, according to Newton's second law, mass multiplied by acceleration. And we know that acceleration is change in velocity with respect to time. Here you can put the values. See, force is, mass is given 5. Final velocity is given 7, initial velocity is 3 and time is 2 seconds. Now you can solve it. 5, 7 minus 3, 4, divide by 2 and we get 10 newtons. Now see, if this force 10 newtons is applied for 5 seconds, we have to find out the final velocity. Same formula we have to use as F is equal to mass into acceleration, m is v minus u by t, and from this expression we have to find out the expression for v. We can write here Ft is equal to mv minus mu, or mv is equal to ft plus mu, and v is equal to ft plus mu divided by m. v is ft plus mu divided by m. Put all the values. Force is 10 newtons, time 5 seconds, mass is 5 kg, initial velocity is 3, divided by mass, same mass 5. Now calculate, we get 50 plus 15 divided by 5, or you can write 65 by 5. So answer will be 130 meter per second. So this will be the final velocity. Let's solve example 9.2. Now see the example number 9.2, which would require a greater force accelerating a 2 kg mass at 5 meter per second square, or 4 kg mass at 2 meters per second square. It means two masses are given and their accelerations are given. So we have to find out the force in each case. And at last we have to tell which would requires a greater force. Which force is greater? So see, if we talk about the first mass, I am representing mass of first body by M1, that is 2 kg. And acceleration A1 is 5 meters per second square. And for second mass M2, 4 kg. And acceleration is 2 meters per second square. According to Newton's second law, F is equal to mass multiplied by acceleration. Here I am denoting this force of first object by F1, M1, A1. So force F1 is equal to 2 multiplied by 10. F1 is 10 Newton. See second object, same, as F is equal to MA, F2, M2, A2. Then F2 is equal to, M2 is 4, A2 is 2, F2 is 8 newtons. Now you can easily tell which force is greater. Clearly, F1 is greater than F2.
Next examples we will discuss in next module.